Now let's start with Hive. So the first question in Hive, what is actually a Hive name? Hive allows users to read, write, and manage petabytes of data using SQL. Hive is built on top of Apache Hadoop, which is an open source framework used to efficiently store and process large data sets. So if you take Hive, it's just a query engine on top of Hadoop. As I was telling you during the session, if this is your HDFS, this is your Hive. Just the Hive would be going on top of it. So it would queries whatever the data comes into HDFS using its query engine and show you the data or process the data. That's the first question in Hive. Let's go next. What is Hive architecture? This is a pretty common point which you usually come across. What is Hive architecture? Now, in this Hive architecture, they may ask you a question directly. Can you explain Hive architecture? It's pretty simple. If you take this Hive architecture, okay. So first of all, once you trigger any Hive query, first that reaches to the driver, right? Then that driver will send that to a compiler for syntax and semantic check. Syntax in sense, if I missed anything in the syntax during select star from and all, or semantic issues means I may trigger my table correctly, select query correctly, select star from table name. The query is correct, but what if the table does not exist? That is semantic errors. That will be checked in the compiler. Then one compiler checks the metastore and confirms, hey, this is correct. Then driver will send that to the execution engine. In our case, execution engine can be MapReduce by default it uses, but we can change this to test engine or Spark engine also. All right. Then that execution engine submits the jobs to the job tracker or resource manager, and that gets to a kind of a distributed environment, contacting the name node, data nodes, and the MapReduce jobs. So in our words, if I want to elaborate it, once query is triggered, first driver takes the query and send to compiler to check syntax and semantic checks, and send to execution engine. Then execution engine query the data from Hadoop using YARN and show the data or process the data. This is the small Hive architecture. Let's go further. What is Hive Metastore? Very important question in interviews. The Hive Metastore is simply a relational database. It stores metadata related to the table schemas or create to easily query big data stored in HDFS. When you create a new Hive table, the information related to schema, column types, data types is stored in the Hive Metastore, a relational database. Hive can use two metastores, folks. Embedded metastore, which is a default metastore, which is a Derby, or remote metastore. It can also use SQL also. So this is not to store the data, just to save the metadata of it. Imagine if I have a table, if I'm creating a table on top of HDFS in the format of, hey, let's create a table with ID and name. I'm creating two names. Then the table information about ID and name would be saved in the metastore. ID is int, name is string. This data gets saved in the metastore. Data would be sitting in HDFS only, but metastore stores the data about the columns. Two types of metastore, embedded metastore and remote metastore. Let's go next. Types of data loads in Hive. We can, if once we create the table, okay, whenever we create the table with location or without location. Hive has its own warehouse. Now, if I create a database, it creates a directory. If I create a table, that creates this, right? So if I'm creating a table, actually, then if I can able to load the data from Edge node using load data local in path, or you can also load the data from HDFS using load data in path. Local will not be there. All right. Now we can say we can load from HDFS on its Edge node using load data local in path, load data in path. Let's go next. Very important question. Types of tables and its difference. We have two types of table, managed table and external table. As every table is pointed to HDFS directory, If we draw the managed table, the backend directory associated with the table gets deleted. As every table is pointed to HDFS directory, if we drop external table, the backend directory do exist and only table gets deleted from Metastore. And managed table is used especially for the temporary purpose. If I want to process it and I want to write the data. External table is for permanent purpose, right? If I have to query the data, I'll keep it as such. If you drop also, data would be on the safe zone. So if you talk about managed table and external table, if I have HDFS, if I have two directories, I may create one managed table and I may create one external table, right? Managed and external table. Now, in this case, if I draw the managed table, directory gets deleted, the backend. But if you draw the external table, directory does exist. And most common question you may face is whether multiple tables can be created on the same location. Also, multiple tables can be created under same location. That could be managed or external. That doesn't matter. We can create, right? So this is your types of table and its difference. Let's go next. Hive warehouse. Hive warehouse is like a Hive's personal room for creation of directories and tables. If we create a table without giving the location of the directory, it gets created in the name of the table and my table gets pointed to it. And we also create Hive table with location on top of existing directory. That is also possible. But what is warehouse? For example, if you have a warehouse, it's just a Hive's personal room. There is a personal room for Hive. While you create the table, imagine if I want to create the table, for example, on ST tab, if I give the table location for the Hive, some directory location to the Hive, it will directly go and sit on top of it to query the data and show it to you. If I don't give any location to this table while create table name, and if I give the location, it will go and sit some directory location. But if I don't give the location, this gets created it creates its own directory and sit on top of it. The name of the table would be ttab. The name of the table gets created and help you for the queries. Ultimately, Hive needs a directory to get pointed to help you to the queries. That is Hive's warehouse. Let's go next. Very important, very important question during the interviews. Hive versus SQL. So SQL is a purpose of, it is ETL. This is ELT, right? So what is the difference between ETL and ELT? First of all, SQL is a database, Hive is just a kind of a warehouse. So ETL, SQL cannot accept any kind of data you put. You have to extract it, you have to transform it, and you have to load it. Hive, we can extract it and load it directly. Later on, we can transform it because Hive supports semi-structured data also. If Parquet sits in HDFS, it can directly pitch in. But SQL needs a transformation before we load it to SQL. Load time parsing, query time parsing. During the load itself, schema validation would appear. In other words, load time parsing, we call it as schema on load. Schema on write. In other case, this is schema on read. That means during the write itself, the validation will occur. If any data type issues are there, SQL will set it to 0 or it will not allow. But in case of Hive, it will allow the data when you load, but when you query the data only, the validation will occur. That's the reason query time parsing. For SQL, there is no serialized data support. You have to do the transformation and load. Hive can support very good serialization data support. SQL is good for small data. If the data is increasing, it will cost a lot. Hive is good for large data, but not good for small data. SQL is licensed, Hive is free. Let's go next. Very important question. What is difference between order by or sort by? We should use sort by instead of order by when we have huge data sets, because sort by class sorts the data during multiple reducers, whereas order by sorts all the data together using a single reducer. Therefore, using order by against a large number of inputs will take a lot of time to execute. Imagine if I have so many data, so many nodes, if my MapReduce job has run, imagine my data sitting at multiple locations. My data is sitting at multiple locations. Imagine this way. Now, if I trigger a MapReduce job, imagine there is another node sitting here. Now, what would happen? Now, this will create one separate result, separate data set. This data set, results I mean, this creates a separate results, this creates a separate results, and this creates a separate results. This will create individual results. Now, if I use order by, all the data will come into single node and get sorted. All the data will come into data node and get, in one of the data nodes and get sorted, which will take a lot of time. But if you use sort by in the query, select star from table name, where class order by or sort by, it will do internal sort here itself. It immediately gets sorted in the reducer side itself. Then, since half of it's already sorted, then it will go and get sorted once. So that instead of sorting the whole data set, we already partially sorting it before going to the sort. Sort has a greater advantage. That is order by and sort by. Yeah, this is a definition. Let's go next. Default delimiter of Hive. It is asterisk A. We call it as asterisk A. Yeah, it's not text file, it's asterisk A. Scheme evaluation is in Hive. Yes, it is supported in Hive, provided if it is table is created with Avro file format, as we have ABSC file to manage the schema. We have seen a very big session on it. Very important topic, partition and its types. Hive supports partitions by dividing the data into multiple folders or subfolders for efficient querying. It is a very good performance tuning thing. Low cardinal values, which is low distinct values, are chosen to perform partitions. We have two types of partitions, static and dynamic, right? Now, what is static and what is dynamic? So, if I have the data, all right, if I have the partition table divided, imagine if the partition, I have created one partition table. All right. Now what happens? If I have a data, all right. Now if I have India data, US data, and UK data, they may ask a such question also, which column is better to choose? We call it as a low cardinal columns. What is low cardinal columns first? Which column to choose means low cardinal columns. For example, 1, 2, 3, 4, 5, 6. If I have this, if I have I0, Emma, okay. And if I have US, UK, US, India, it's always better to choose this column. This is low cardinal. That means I can categorize US separately, UK separately, and India separately. But I cannot apply on these two columns because there's a highly distinct, many changes. And it's better to say in our project, we're using date as a low cardinal. You can say like that. In many projects, we can use date also. If I have two dates, I can segregate. Imagine US is one date. Like that, date can also be used. Now coming to the partitions. If you have a partition table, if we already have the data segregated, separated, you can load it India data separately, US data separately, UK data separately, and you can mention the column name here, US and UK, like this. But this is static partitions. Data is already divided. These are static loads. If I have dynamic partitions, for example, if I have all country data at one case, if I have all country data and they want only the US data here, for example, in the name of US, you have to load this table data into one table first. You have to handle it through static insert. While inserting the data, you have to handle the static insert. If it's a dynamic insert, They're expecting all the country data to come up, UK and India. Then you have to load the whole all country data to a staging table. From this staging table, you can insert the data here. Mostly this would be managed table because this is a temporary table. This would be external table. Better to choose. Yeah. So this dynamic partitions can be handled. To achieve the dynamic partitions, when you do an insert statement, last column should be mentioned in the select. That column is considered for the dynamic partitions, right? And you can also obtain the sub-partitions also. Many column, one or more than one columns can be given in the partitions. There is no limit. That's the partitions for you. For detailed explanation, please watch my partitions video. Let's go further. What is bucketing? Right? Bucketing is used for highly cardinal columns for query performance. We can use bucketing along with partitions also. Bucketing also helps for joins during bucket to bucket join. Buckets are files. Partitions are folder creation, folks. Buckets are the files. What would happen? In the same scenario, let's imagine the same scenario. Imagine what if I do not have this low cardinal column. All the columns are highly cardinal. So how to create that? Now I can create a bucketing here. On top of this column, I can create bucketing. Please check the bucketing video which I have provided, right? So in case if I came across the highly cardinal columns, that's a major difference. When to go with partitions and bucketing. If I have a high cardinal column, I'll go with bucketing. If I have low cardinal column, I go with partitions. In this case, I can create a bucketing on the ID column. So it will provide a hash algorithm. Hash algorithm. What is hash algorithm? So it will perform a kind of a quotient, like a reminder calculation, and it will segregate into files, not the folders. All right. So if I perform buckets, imagine if I'm saving it into 3 buckets. ID column should undergo 3 buckets. So 1 divided by 3, it will go to 1, reminder 1. 2 divided by 3, 2 reminder. 3 divided by 3, 0 reminder. Then next, 4 divided by 3, 1. So fourth data will go to this file. 5 divided by 3, 2. So this data will go here. 6 divided by 3, reminder 0. I'm talking only the reminder. Okay, 0. So all the reminders of 1 will go into one file. All the reminders of 2 will go to other file. All the remaining will go to the 0 will go to the other file. We call it as a modulo operation. In other words, we call it as a hash algorithms also. Like that, I can create a buckets on ID column, right? So it's a modulo operation. As per dividing number of buckets as 3, 1 divided by 3, reminder, 2 divided by 3, reminder, 3 divided by 3, reminder, 4 divided by 3, 5 divided by 3, and 6 divided by 3. Accordingly, files gets generated. So 3 buckets means 3 files. So the querying becomes faster on these files, provided you have to provide filter on IDs. So this is bucketing. In other words, as a difference, partitions as a folder creation, bucketing as a file creation. Partitions are for low cardinal columns, bucketing for high cardinal columns. We can apply subpartitions in partitions. That's just a folder creation. Bucket is a file. We do not have sub-buckets because we cannot create file inside a file. And also, bucket is used for joins. That's bucketing for you. Next, default partition size. At a stretch of insert, we can create maximum of 100 partitions, right? But if you want to change the property, you can set it to Hive exec maximum dynamic partitions is equal to 1000. Like that, we can increase the limit. Next, DML in Hive. Very common question. In real time, we may not use it, but towards interview, you will face it. Whether insert, update, deletes are possible. Yes, Hive supports updates also and deletes also to a table. But major thing is that should be transactional true. That should be ORC file format, and the table should be bucketed, which I have highlighted here. 3 buckets, ORC, and transactional true. If I can able to create a table like this, and if I query the data, or if I insert some data, we can happily update it and delete it. Possible, but you should have 3 things: transactional table with bucketing as well as ORC file format. Yes. Let's go next. Very, very important question towards interviews. What is MSCK repair in the table? They may not ask you a question like, what is MSCK? They'll give a scenario and you have to answer it as MSCK is a solution. What is MSCK repair at the hive? MSCK repair is applied for the hive table to recognize the partitions which is created by other hive table in the same location. Imagine there is a hive table, partition hive table. All right. Imagine table 1. I'm creating something known as table 1. If I created that as a table 1, if the partitions got created, imagine if the partitions has got created. During some inserts, table to table insert, some partitions has created. Imagine country partitions are created. India transaction, India, US, UK, if it is created. But if I create another table on the same location, table 2, after the partitions gets created, then if you select start from of table 2, none of the India data, UK, the data do exist, but it will not recognize it because these partitions are created by the table 1. Now what you have to do, you have to trigger a command known as MSCK repair table 2. Then the partitions get recognized in the metastore. Hardly takes some seconds, repair will happen. After repairing it, table 2 can also recognize the existing partitions created by some other table. That is what MSCK repair for you. Let's go next. Very important question. Performance tuning in hive. Vectorization. Yes, we can have high vectorization as one of the possible performance tuning point. By default, hive can able to process only one row at a time. But if you can able to enable this property of vectorization, it would process 1024 rows at a time. Secondly, parallel execution. What is parallel execution is? If I have any, for example, by default it is false, actually. But if we have subqueries, hive have to wait to process first subquery and to handle second subquery. But by enabling this property, both the subqueries gets executed parallelly. This is what parallel execution means. In other words, imagine this. If I have a subquery 1 and subquery 2, if it is a false, first this gets executed, then this gets executed, this gets executed. Finally, the total select statement. If I enable this parallel execution true, then this one and this one together it gets executed. Stage 3 will execute at the last because this 2 will be under parallel execution. So that's what I have given. So recheck it. If we have subqueries, hive have to wait to process the first subquery and to handle second subquery. But by enabling this property, both the subqueries gets executed parallelly, like this. This gets executed together, this one and this one. Then the stage 3 gets executed at once. But memory consumption would be huge. Partitions and bucketing. Yes, dividing the data into multiple chunks to ensure the query performance. Map side join. This is quite important, folks. Mostly they would expect this as one of the point to be highlighted. In case of map side join, what would happen is, imagine if I have two tables. Table 1, concentrate. Table 1 is a bigger table, imagine. Table 2 is a small table, imagine. Right? So table 1 is a bigger table, table 2 is a small table, right? Now check, what is map side join? When two tables are getting joined, one is a large table, other is a small table, it's better to perform map side join with a small table so that whole small table would traverse to the cache of all the data nodes of the first table to ease join. How that works? Imagine I have 4 node cluster. And this data would obviously gets into chunk. This data obviously gets into chunk. I'm dividing this data into first half, this one, and this data I'm sending it to the second. Now this is a small table. This small table also, this data will be chunked in. This data will be chunked in. Now we have a syntax for map side join. So let me show you map side join. We have a syntax for map side join when you query the table. All right. Yeah, if you take this table, this is my join query. When I trigger this join query, this is my actual join query. When I'm joining this query, what I'll do, I'll make second table as a map join. I'll make it the second table as a map join. So select map join of second table, any table name you have. That time what it will happen, this whole data, this data will come here, the second chunk. From here it will come, and this data gets added to this actual chunk. It will be full chunk of second data. This data will go and sit in all the data nodes where I have the first table. That time join can easily happen searching its respective IDs here itself, or else the lot of shuffling will happen, which causes a lot of performance issues. Now, when the second table, which is a small table, comes to the cache of each and every data node where I have the first table, join happens faster. You need not to search for in which data node I have the IDs, not required. It will get into the cache and join happens very fast. That's the one which I have told here. Next, we can change the Hive engine, right, to a test engine or Spark engine. Once we set this property, it would be a bit faster. Test engine and Spark engine works on in-memory computation far better than the MR engine. But test engine predominantly supported in the Hortonworks. This is your performance tuning in Hive. All right, we can change the engines also. Next, sort merge bucket join. Sort merge bucket join is nothing but it would help to join bucket to bucket of 2 tables. But these 2 tables should have equal number of buckets. Imagine I have 2 tables. If I want to perform, imagine I have HDFS. In this HDFS, I have 2 locations. In these 2 locations, I have 2 tables. This is table 1 and this is table 2. Imagine I have 3 files. Three buckets. And if I have same 3 buckets here, buckets is nothing but files inside. Usually the bucket gets created in this name 0, 1, 2. Imagine, because the reminders would be 0, 1 or 2. Now bucket to bucket join will happen. Between these 2, a join will happen. You need not to scan the whole table to find its key to get joined. This bucket join will help you to bucket join. This bucket will happen between 2 and 2. So like this, the join would be a bit faster to accomplish the joining these 2 tables. That's what sort merge bucket join. It would help you to join bucket to bucket of 2 tables, but these 3 tables must be having equal number of buckets. Then only bucket to bucket search would happen. Next, indexing. One of the Hive queries optimization methods in Hive Index. Hive Index is used to speed up the access of a column or set of columns in Hive database because the use of index, the database system does not need to read all the rows in the table to find the data that one has selected. See the query here. Create index table 1. I'm just creating an index table on table 1, column 2. Now what will happen if one of the columns has been indexed? Check here. If I have the table and I have a column, imagine my column is ID. If I'm indexing this, if I indexed this, right? I'll create one index. Index name is, for example, IND1. I'm creating an index known as IND1 for this table. Now that time, check here. I can index a column. Create index. I'm creating an index to a table. Index name on table 1 of column 2 as compact. So it will create an index. So when I perform an index column or filters or processing of this ID, which is associated with this index, it would be faster in query, right? But which is almost equal to the partitions, but predominantly indexes are not used. But you can create if required for a table or on a column, so that when you perform any queries on this table with only this column, it would be very faster. But it's almost similar to partitions, not as much as it is used. Yeah, that's the indexing for you. High views. Is it possible to create high views? Yes. A view allows a query to be saved and treated like a table. It is a logical construct as it does not store data like a table. In other words, materialized views are not currently supported by Hive. Hive does not have a predominant view support, but still views are supported. Question could be whether view can be created on Hive. You should say yes, but you can happily say that I have not worked on it. All right. Yeah. Limitations of Hive. Hive is not suitable for unstructured or small data. Real-time streaming is not that supported. It exists, but not as much as real-time it is. Updates are not as easy unless until that conditions. Transactional ORCR's bucketing table. Let's go next. Renaming a table is possible. Yes, we can rename a table in Hive. Alter table name, rename to table 2. We can give like that. We can rename a table from one database to table 2. Test 1 table to test 2. Possible. Change data type of a column in Hive. Is there a way that I can change a data type from begin to int into begin, or begin to string to float to date? We can by triggering this column. Alter table 1, change TS. All right, TS is a column name here to begin after ID. If you want to place any column after this, you want to place this column after any column, you can give this. But as a raw syntax, this is a way you can change the data type of a Hive table column. Let's go next. Serde in Hive. Serde is nothing but serializer or a deserializer and deserializer. A Serde allows Hive to read data from a table and write back to HDFS any custom format. The format can be Avro, Parquet, ORC, or XML. Hive uses its own Serde to deserialize the data and show you the readable format. Let's go next. UDFs. See, I may have some UDFs. I mean, an inbuilt function like max, min, average, like that, or lead or lag. But we can also customize UDFs in Hive. You can say that you have not created one, but you can say it is possible. User-defined functions, also known as UDF, allow you to create custom functions to process records or group of records. Hive comes with comprehensive library of functions. There are, however, some omissions and some specific cases which UDFs are the solutions. Very, very problematic. Somehow Spark has already replaced it in all possible ways, but still, if you want UDFs in Hive, it is possible. You can create yours in Java. Let's go next. Yeah, very important. Hive Unix run. Once you develop some queries, imagine I develop some queries. All right. If you can able to create some queries, create table name, insert into table, drop table. If I have set of queries, how can you make it as a shell execution? Ultimately, Scoop, Spark, Summit, or Hive is completely the execution scripts. So you can make Hive in two ways to get executed. Hive-E and give all the queries like this with a semicolon delimiter. Set into table or drop table. All right. You can execute like this and we can have this command as a script. Imagine I'm saving this in a script and save it as a run.sh. Imagine I'm creating it as a run.sh. save. And you will file run.sh like this. And what you can do, you can run it even in the edge node or something. You can automatically run it. For example, if running into the edge node, ls sh run.sh. If you run it, Hive gets executed, but Hive is not installed in my system. That run has my hive-e command. This is one among the steps to ensure save it into a single file and run it. Or else you can save the set of commands in a file directly and save it, run one.sh. You can save it like this. All right. You need not to create hive-es and all. You can have all the commands in a file, right? Now, once you are ready, then you can run it using hive-f run one.sh, right? You can create hive everything in a single file, and you can run using hive-f, and you can in the run one.sh has completely the script of hive. That you can have a sh extension or HQL extension to the existing file. I mean, when you create a file itself, you have to provide the script name. This is hive-e execution or hive-f execution. We don't go to the shell and keep executing everything. We'll create an executable file consist of all the commands and we execute it. This is Unix run. Thrift server. What is Hive Thrift server? A service which permits a remote client to submit requests to Hive with the help of a variety of programming languages as well as retrieve results is what we call Hive server. Since it is built on Apache Thrift, we call it as a Thrift server sometimes. First of all, this is my cluster. Imagine this is my cluster where my Hive is running. I have HDFS. I have Hive. Imagine Hive is running at the top. But if anyone want to connect from the external system, imagine you want to connect through Eclipse from a different cluster you want to connect by using Python, using Java or something. We have to use through Thrift server only. Using Thrift server, you can connect to this Hive from external systems. You can inform this, but you can connect through Hive Thrift server. This you can do. This is your Thrift server. Now, that's it. Next would be the Spark. Get tuned, folks. Get ready.